Hi, everybody. Welcome back to Dave's Math channel. I'm your host, David Tear, and I haven't made a video on this channel in a while, and I think it's high time I do so. And since the election's coming up, I figured I'd do a lecture on polling where I explain how poll results are analyzed. So anyway, let's begin. So I'll start with this is a recent poll that was done for Arizona. Arizona, as you guys probably know, is one of the battleground states for this election. Very close between Harris and Trump, as you can see. Well, Arizona's the one on top. These are actually seven swing states. And I'm just going to concentrate on Arizona. So Arizona, I guess, was the most pro-Trump of all these states. 50% of voters said they were planning on voting for Trump. 47% for Harris, and 3% were undecided. This was August. I think it's more for Harris now. At least I hope it is. But anyway, so you might wonder how what exactly this means. How did we come? How were the pollers able to come up with the results? Obviously, they didn't poll everybody in the state of Arizona. That would have been way too difficult. They probably just did a random poll of around 1,000 people. I don't know. They don't say here how many people they poll, but they do say what the uncertainty is. They say it's somewhere between. I think they say the uncertainties of all these percentages is between 2.8% and three. What is it? 3.4%, 3.6%. So you might wonder how they came up with these uncertainties, and so before we go into that, I guess I have to explain to you about how polling is done. Well, I mean, there's different kinds of polling. There's different kinds of sampling. Whenever you do a poll, you're always starting with a sample of the population you're interested in, and the simplest kind of sample to analyze is what's called a simple random sample. This means that the people you choose in your poll are chosen completely random, meaning that every person you've chosen has an equal probability of being chosen among all intended voters in this whole state of Arizona, which is quite a few. Arizona is a pretty big state. I think it's something like population something like 7 million, and I think probably about 40% of them are going to vote, so that's about 3 million people. Obviously, you can't pull all 3 million intended voters. So you just do 1,000 at random. That means that each intended voter has a probability of about 1 in 3,000 of being chosen for this survey. And of course, once if you've done this, you expect that the actual percentage, say that let's just talk about the percentage of people who are going to vote for Harris. We can call that P. That's the actual percent P hat. That's the actual percentage. We expect that's going to be approximately equal to the sample percentage. I mean, that's reasonable, right? Because if we've just chosen everybody at random, then there's no reason to believe that the actual percentage is going to be higher or lower than that if it really is a random sample. And so that's how we get the estimate the sample percentage. So for example, for this, since we found 47% in the survey, 10. This is what the survey says. We estimate 47% of the voters in Arizona are going to vote for Harris. That's probably because 47% of the people we sampled said they were going to vote for Harris. I mean, that's just so that makes sense. We don't expect that actual percentage to be any different. But what about the uncertainty of our estimate? Well, here's where we use some statistics, and I'm sure you guys are all familiar with a bell curve. I did another video on this. I've done a few videos on this, I think. So I think you guys have all seen the bell curve, and you kind of know what it means. It has other names too, normal distribution or Gaussian distribution. But the idea is it always has this kind of bell shape, characteristic bell shape, and you can look at how many standard deviations away from the mean, what percentage of your data lies within a certain number of standard deviations of the mean. And it's well known that within one standard deviation is about 68%. 68.26% more precisely. Within two standard deviations or two SDs, you get about 95.44%. And then within three standard deviations, it's almost all your data is 99.72%. And usually when you do what's called hypothesis testing or confidence intervals, which is what we usually do when we get this polling data, usually they do the 95% confidence interval, which is roughly two standard deviations. To be more precise, it's actually 1.96 standard deviations if you want to get exactly 95%. If you don't care about being exactly 95%, you can be a little rougher. You can say just two standard deviations and you're getting 95.44%. That's actually a little bit of a better confidence interval. But I'm going to assume for this problem that it's exactly 95%, which means I'm going to do 1.96 standard deviations. And so that's kind of the idea. You want to do this confidence interval, 95% confidence interval, which is going to mean that there's a 95% probability that the actual number of voters in Arizona tend to vote for Harris is between some lower limit and some upper limit, centered around the mean, which in this case is 47.4%. Uh, but how do we get the standard deviation? That's the next thing we need to know. Well, it turns out there's a formula for it. I'm not going to derive this formula, but it turns out the standard deviation of the mean of all the sample data is equal to square root of p times 1 minus p over all over n, where n is the number of people we've sampled. So that's going to give us our estimate of the standard deviation of the mean. Sometimes we just write sigma for the population mean, which is p square root of p minus 1 minus p over times 1 minus p, and then we divide the whole thing by the square root of n, but I'm just going to call this thing sigma. So anyway, that's how we calculate it. And here's just a picture of what's going on. So we have our expected value in the middle, which in this case is 47%. And then we have to calculate the uncertainty, the 95% confidence interval. I'm going to call this error E. They don't use it here, but X1 or XL, that's the lower limit. This is going to be X hat minus E, and the upper limit is X hat plus E, where E is 1.96 times, here they call it S. I was calling it sigma. So 1.96 times sigma divided by square root of n. So that's how we calculate it. And we already have a formula for sigma. It's square root of p times 1 minus p. So that's all we have to do. So now let's just do an example. I'm being a little more precise here. I don't know what the exact data was for the survey that was done, but I'm going to assume that we've sampled 1,000 adults who intend to vote in the upcoming presidential election. We selected them at random from all voters in the state of Arizona. And we found of all the people we sampled, 474 said they intend to vote for Harris, 502 say they intend to vote for Trump, and the remaining 24 are either undecided or they're going to vote for someone else. So anyway, so we only, like for the example I'm giving, we only care about Harris here. So I'm going to call P the sample percentage. That's the percentage of people we've sampled who intend to vote for Harris. That's 0.474, just 474 over 1,000. 1,000 is our samples size, and and then to get sigma, the standard deviation of the mean, here I'm dividing my square root of n as 1,000. So we just plug in the formula. It's the square root of p times 1 minus p over n. And when you calculate that, you get 0.01579, or about 1.6%. So anyway, that's how we calculate the sample standard deviation, and our best estimate of the population standard deviation is equal to that. But we don't just care about the standard deviation, we care about the error, which is equal to 1.96 times the standard deviation, because we want to construct a 95% confidence interval. So we multiply sigma by 1.96. And if we do that, we get about 3.1%. That means that our error, our uncertainty in the actual population percentage is about 3.1%, which just happens to be halfway between 2.8 and 3.4%, which was voted. In the survey, that means I'm pretty sure they did sample 1,000 people. That's pretty typical. Usually, when you do a statistical survey, you sample 1,000 people, and usually when you do that, if the percentage of the thing you're measuring is close to 50%, you do get about a 3% error. You'll see this a lot when you look at when you look at poll results. Just keep this in mind. The percentages that they estimate are within about 3%. So in this case, that would be between 44.3% and 50.5%. And notice that it's not that unlikely that actually more people in Arizona will vote for Harris than for Trump. The probability of that happening is greater than 5% because this confidence interval overlaps 50%. It could be that the majority of voters in Arizona do actually vote for Harris. And this is assuming, keep in mind also, this is based on a survey that was done in August. And I think survey results have changed since then. Um, I think it's my understanding that more voters are now going for Harris. So I think it is pretty likely that Harris will win in Arizona, even though she was behind when the survey was done. Anyway, that concludes my video on polling. Thank you for watching. Long live math, and I'll see you guys next time. Bye.